will do today. Okay, so this is something which we will do today, guys. And the idea is that whenever you are doing something like an task-oriented chatbots, okay, the functioning of it is very limited because they serve as in single-purpose programs, right? And again, in terms of an example, the one which we can see is like something like an IRCTC. Okay, and I think I will classify the big basket app. I'm not sure if they have revamped their apps, but I see their apps also something like this. So whenever you go to a chat program, you will have certain, options, okay, and you can just check from these options, and based on that, it will give you another answer, right? So it's basically used for performing one function at a time. So you cannot, ask any question, even though it's in line with the topic, but it cannot be in free flowing conversation, right? So these are like more about what we see as like the classical chatbots, right? They basically leverage like NLP or natural language processing, very little ML, which means not much of machine learning, not much of deep learning models, right? More of, I would say, heuristic models, more of rule-based models, and they generate automated but conversational responses to the user inquiries. Okay, the important then these inquiries are highly specific and structured, right? And they are not like, it cannot be free flowing. Okay, so I would say from an application point of view, or if you will see Indian like India's market, and the penetration of chatbots, and let's say if you divide it into two, so these are the ones which kind of have major proportion in the bot market, right? So the industry is still not advanced to make as I would say conversational bots like Alexa. If I take an example, but yes, these are the ones which is more prevalent. Okay, and this is something which we'll try to see in terms of a case. Okay, but having said that, there's also another one which is there. And what are these? These are the ones which we are saying as these are the ones which we are saying as a digital assistants, right? So what are these? These are often referred to as virtual assistants, right, guys? And obviously, given the nature of it, they are more sophisticated, interactive, and personalized. Most important thing is personalized, right? So who doesn't want a personalized conversation, right? So with Siri, it tries to be as personalized as you like a friend, right? So it can give you recommendations based on your past history. It can give you play the songs which you want, or give a good playlist, or do things, maybe order a food from Zomato, or let's say book a cab from Uber, and do all the intelligent things which you would want it to do, right? So here the context is, it is more sophisticated, interactive, personalized, right? And these bots are always learning. The most important part of these bots are, they are always learning, right? When I say learning, they are basically learning from the data that you're generating, from the data it is trying to learn. Okay, so there is also an it's not always a, I would say, good picture. There is also challenges about how much it should run, how much data privacy should be there, but that's a completely different topic, which I do not want to go into right now. But yes, that's basically the USP of these bots. And in addition to monitoring and data intent, they can initiate conversations, right? So Apple Siri or Amazon's Alexa are the prime examples of these, like consumer oriented and data driven bots, right? So they can even initiate a conversation, so they can be predictive, right? They are not always responsive, they can be predictive as well. Yeah, so these are another, I would say, a class of bots, guys. As I said, like now in context of the Indian markets, it's mostly I would say the traditional bots which are in picture, but definitely these bots are gaining momentum, and a lot of startups are working to make these kind of bots, right? And make them in application, make them in picture, where it is using a high-end and sophisticated techniques like natural language understanding, natural language processing, or even natural language generation, NLG, along with machine learning and deep learning models, to basically make it as predictive as possible. Right. I will hold on for a moment here, guys, and I want you to absorb all of this. I'm sure I'm talking a lot, and it might be a lot of times a lot of information to digest. But I'll stop for a moment and let you guys ask any questions, anything, any thoughts which you wanna ask. Yeah. So let's make it as interactive, guys, and let's not make it just a monologue. So yeah, happy to have any thoughts, any comments, any questions from you guys. Firstly, this all makes sense. I hope it's not sounding Latin, and it does make sense, right? And in the given scenario, in the given context of being digitally oriented and using bots and using a lot of apps. Yeah. Okay. Somajit asked, does English language is the only supported language for conversational AI applications? Somajit, no. So in Google, so there's with in bots, basically one of the another prime player is Google. Okay, so Google has an API inbuilt. Okay, so which can work in local languages also. When I say local languages, it can be across geographies, like in India, it's Hindi, right? In China, it is Mandarin, right? So it depends upon how strong that API layer is. It also depends upon how much it has learned, right? So obviously, English is like the prime language which is used across, I would say, geographies, and hence there is a lot of history to train with, right? But in context of local languages, there's not a history to train with. There's not a lot of ground truth available. So yes, there is. It's not like that English is the only language. But for other languages, I would say the sophistication of that bot will be less. So if I say for Alexa in Hindi or Siri in Hindi, the sophistication of Siri to have the conversation is will be relatively limited as compared to its conversation in English. Does that answers your question, Samajit? Okay. Okay. What else? Any other thoughts, questions? Do let me know. With me till here, I hope everyone.
Hello, sir.
Yeah, yeah. Go ahead, Devesh.
So what is the difference between deep learning and machine learning?
What's the difference between deep learning and machine learning? Good question. Okay. So generally, what we see as a machine learning, guys, that machine learning is generally the point where we are seeing that we are training an algo to do something. Okay, and the basically the universe of machine learning is all right. Deep learning you can consider as a subset of machine learning. Okay, why so? Because in ML, what we are doing is you are training any algo to do something repeatedly and predict. Making sense? That is what ML is, or machine learning is, right? And here you can talk about any algos, like from ranging from random forest to gradient boosting to cat boost, right? Name base, anything, right? Why deep learning is considered to be a subset of machine learning? Why? Because these are brain inspired techniques, okay? Or like example of, let's say, LSTM or RNN or CNN, right? These are all inspired by the way human intelligence work, right? And they basically play a subset role or a small role or branch in machine learning. The one key specification of deep learning is that they generally work on three set of unstructured data, which can be either images, right? The second can be basically speech, right? Sorry for that, for the handwriting. And the third can be basically text, right? So in context of unstructured data, your deep learning kind of frameworks does work, right? Better. But then if you see like what's basically the role of deep learning versus ML, it's mostly deep learning being as a subset or a branch of machine learning. Making sense?
Yes, sir. So computer vision is come under deep learning.
Yeah, computer vision problems are generally solved by deep learning techniques because you have a lot of unstructured data in terms of images and videos, right? That's where deep learning is a better technique to handle.
Okay, sir. Okay, sir. Got it.
Yeah.
Thank you.
Okay. Okay. Great. So yeah. Also, let's try to talk a bit about NLP in the role of chatbots. Okay, what NLP does. So NLP is basically, or before the NLP era, right? So how chatbots used to work is it basically used to work in terms of an the concept of what we see as pattern matching. Okay, so what is pattern matching, guys? So I'm not sure how many of you guys have heard about something called regex. Okay, what regex is basically it does pattern matching. When I say pattern matching, what it means? It basically means that if your text have got certain patterns, right? So it tries to match that pattern, and based on that pattern, let's say you have a certain rule, then that rule will be implemented, and that will be basically the answer, right? So to give you an example, let's say there are three texts. Okay, what is your name? Okay, the second is uh, let's say let's try to frame it in a different way that hey, what is your name? And let's say the third statement is okay, good, and what is your name? Okay, so both of these three statements includes what is your name, right? And what regex in this context will do is use words like find words like what and name, right? And try to, and we know that, okay, so in any of this, the response should be actually the name, and it should basically give you the name from a bot perspective, right? So this is what pattern matching does. So it basically tries to identify certain patterns in your data, and based on the pattern, it will try to generate a response, right? So these are mostly rule-based or heuristic. Okay, it's not machine learning. It's more of, I would say, rule-based techniques, right? So that's what pattern matching. That's what pattern matching works with. But with the advent of, I would say, NLP era, guys, what we are viewing is like there are a lot of NLP techniques like tokenization, normalization, and a named entity recognition, and all of this, right? And this basically becomes like a fundamental viewpoint for chatbots, right? I'll not go deep into this given the constraint of time that we have, but basically what these are doing, they basically help the bot in terms of cleaning the text, right? Because when you are conversing, or let's say whenever you are writing something, right? So the text can be tidy, the text can be dirty, the text can be that needs to be cleaned, right? And all of that. So in all of this case, like tokenization, normalization, recognition entity, this can basically help in terms of your the ability of the bot to respond, right? So that's what NLP does, or what we see as a natural language processing. So it basically cleans the backend text for the model to work well and to generate more accurate responses, right? So that's what your NLP role is. Okay. So other is like dependency parsing and generation. I'm not sure how many, if you guys have seen, and as an example, like when you are writing in email in Gmail, right? Do you see sometimes the words get spelled autofilled, or let's say even in when you are texting, right? So autofilled recommendations, all of that. Seen that?
Yes, sir.
So what is the example of this? This is an example of natural language generation, right, or NLG. So it tries to, so there are models with Google, or there are models, let's say, with Meta, which has been trained like, okay, so please find attached. So if you start writing please find, the next word should be attached. How it is coming as attached? So the model has been trained with, let's say, 10 billion words wherever, and it knows that please find has come with attached. So now it knows that, okay, please find, the next word can be attached, right? So that's how the models have been trained, and that's what NLG refers to, right? And this is where basically Alexa or these predictive bots do work upon, not the I would say traditional bots. But yeah, so these are all examples where NLP is coming into picture and making the bots, I would say, more accurate, more responsive, more intelligent, right? And obviously, there are more layers to it. It's not like this is what when we talk about bots or a conversational AI, there are much more layers to it. And yes, obviously, we can definitely talk from their perspective in many elaborated sessions, right? But I also wanted to take this time to just showcase you that how we can build a very simple bot in Python. So what I will now take you through is to build a bot in Python. Okay, and you guys can really use this code. So I will show this code, and you guys can play with these codes and even build your own bot. Okay, in Python, obviously, and even deploy it from a UI's perspective, right? So basically, that's the next action item for us, and let's try to get going into the Python perspective. Just wanted to have just a a sense check about how many of you we have some prior knowledge of Python, or it's like let's how's the distribution here, just to have a sense check.
What, sir? Can you repeat that?
So how many of you guys are comfortable with Python or have worked in Python? How's the distribution? Just wanted to check around that.
Sir, I have started learning it.
Okay, good. Okay,
Yeah, basic of Python is fine with me also.
basic
Not
of Python.
the, yeah, like understand the data type, how to
Mhm,
prepare
mhm,
simple functions.
mhm, mhm. Okay, so if I would want to understand average it out, it's like mostly we can say we are, it's not completely Latin, but it's we are good with the basics, right? Is that correct to assume? All okay. Sure, has learned good. Okay, so no worries. So let us switch gears to the coding part, and let me actually share basically the coding part. Okay, so give me a moment, guys, before we jump on to the code. Okay. Sorry, guys. My laptop has has been acting up uh, in these days. But let me reshare and let me know if it's visible. Is it visible, guys?
Yes, sir.
Okay, cool. So what we will do is uh, we will be basically building a simple chatbot in Python, all right? And the package that we will use is NLTK, right? And what we will do is basically is we will be we will be basically leveraging the text uh, we will be leveraging all this text from the from chatbot itself. So basically, Elysia, it's basically is like one of the most early chatbots which was introduced, right? So it was introduced way back in 1966. Okay, so what it did, it imitated the language of physiotherapists from only 200 lines of code, right? So you can even converse with Elisa here. So I've pasted a link here. Okay. So so we have done, we have created a basic chatbot using Python's analytical library, and you can use basically, we will be using the NLTK. And in Python, what we need to do is like NLTK is a library which does not comes pre-installed, so you guys can install it and basically work on this entire code repo, right? So let's get started. So basically, I will be using these certain set of packages, which is random strings to process the standard Python strings, warnings to ignore any warnings, NumPy for data handling, OS for setting the directory, and sklearn, which is the machine learning package of Python for feature extraction and for TF-IDF vector calculation. So this basically is part of NLP, right? So where we want to rank the words based on their importance, and we'll also use the cosine similarity. Where I will be using it. Wait for just some minute. Okay. I've also included like how can you install the analytical library, so you can just uncomment this and install it, right? Because the first time when you will be using it, do install it. Okay. So here, basically, I am importing the analytical library. And from here, I'm also importing something like a Word net limitizer. What limitizer does, guys, in short, it tries to return the I would say the root word. Okay. So that's what limitizer does. So it's basically, if you to give you an example, let's consider three words: playing, played, and let's say will play. So what do you think is the root word here, guys? Play, right? Everyone, played, playing, and will play. The root word is play.
Play, sir.
Yeah.
Yes, sir.
So that's what limitizer does. It tries to extract the root word from the various words or tokens that you have, and it tries to retain only that, right? So it doesn't try to retain the different variants of it. Okay. Now that's what we have imported. We will also, we will be using the Wikipedia page for chatbots. Okay. So I've just copied the contents of the page and we have placed it in a title and text file called chatbot.txt. Okay. So, and what we are doing is also just converting into into lower. Okay. So if I show you raw, so this is the text that we have. So it's like it's like the data that we will be using to train our bot, right? So what is the text all about? This text is all about chatbots taken from Wikipedia about what is it, right? So so let's try to use this. Okay, so let's try to use this, and I have written in detail about what are the steps that we are doing. Things like about converting them. So this is all about cleaning the text, right? So so similarly when the bot is in application, you do not expect the customers to write very clean, because bots are object oriented and they need to understand what has been written. So in that case, the cleaning or removing the noise in terms of stop words, in terms of making everything lowercase and all of that is very, very important. Okay. Similarly, stemming and lemmatization is also very, very important, right? So that's what these specific techniques are being used, right? So stemming and lemmatization, they basically extract the root word. Okay. Tokens, what it does, tokens is basically, so send is like send tokens, and I would say, sorry guys, excuse me for that. Send tokens is basically it's like an sentence token, right? So basically the entire sentence, like the entire text that we have can be broken down into different kind of tokens or different sentences, whereas word tokens, okay, let me also show you word tokens, an example of it. So word tokens are actually words. Okay, word tokens are actually words like chatbot, like or let's say let me use something else. Let's say no. Okay, so these are like different words. Okay, so if you see the sentence token, the first sentence. So here, if I use the first index, so it is A, and if I do one, it is bot chatbot, right? So it's basically breaking down all the words into different pieces, and that is what is important for our chatbot work, right? Now what we do is like we need to do some kind of pre-processing. So in terms of pre-processing, the first thing that we do is like we lematize the words. So lematize the words is basically the fact that from tokens we only try to keep the root words. The example that I gave, right, like play, playing, played, right? So that's what the root word is. Okay, and similarly, what we also do, we also normalize the word. When I say normalize, we are basically making every text lower, right? And also we are removing any punctuation marks if applicable. Now, as I said, guys, it's like more of an basic bot. It's not a very, I would say, as intelligent as Alexa. So what we are doing is like, if this is my greeting inputs, like hello, hi, greetings, these are my responses, right? So they are mapped. So they are like, so if you say hello, it can basically give and random random choice on terms of what it can be. So if you're saying hello, it will not that, it's always say hi. It might say hi also, it might say hey also, it might say hi there also, right? It will be a random output. So that's what this part in terms of keyword matching is doing. But now comes the more important thing about generating a response. So if you remember, I talked about, how if you talk if like an ICDC, it's a more of an, it's a constraint bot. So if there is a certain words that we are asking, from those words it tries to from the document that it has. So in this case, the Wikipedia page, it tries to check like what is the most important thing that is available, right? So in or the most common thing that is available. So how does it do it? It basically works on two approaches. One is a TF-IDF. TF-IDF is generally like a score or any feature that we have. And another one is Kassan similarity. Kassan similarity is like simply the dot product of two TF-IDF vectors. So the idea or the intuition is, let's say, if if the customer is asking something, we need to find most similar words or most similar responses from the database, in this case, the Wikipedia that we have, right? So that's basically we are trying to extract the most common or most similar responses, right? That can be that similar words that is available in the corpus, and that can be tagged as responses, right? So that's basically these two approaches, TF-IDF to generate the scores, because basically we are working with words and we need to generate numbers for our machine learning model to work, right? So this I've written a very simple function here. So what it does is like it takes it basically takes the user response or whatever the user is saying, and it uses the TF-IDF to basically create those vectors on the importance of the variables, and then based on cosine similarity, it tries to search within the I would say the database that we have, that what are the most common words or most common text, and it tries to return it. And if it is not able to find anything, okay, it will give you a response of I'm not able to understand you. Okay, so you'll see this in practice. So let me define this function, and then what it does is like, here I've kind of initiated an like a control structure using a while and else if else loop. So it will basically, because the conversation needs to go, right? So it's so basically, if the conversation starts with my name is Robo and I have answered queries about bots. If you want to exit, type by. So whenever we type by, the basically in this case the chatbot or the bot exits, right? Or else it will keep on trying to understand what you're asking, right? So let me show you a live example of this. So my name is Gobu. I will answer your queries. Let me start with maybe hi there. So it says hello. Okay. So let me write something like what is chatbots. Okay. And let's see what kind of answers it is doing. Uh, so, okay. So in 2016, Facebook Messenger allowed developers to place chatbots on their platform. Not the most, maybe, uh, um, I would say exact answer, but yes, it gives like something from that text and what is available, right? So even let's try to ask about something which is there. So this entire text was about Elysia. Okay, so this particular one, this one. So let's try to understand or ask uh, what was Elysia, and maybe also talk um, uh, about who was Alan Tuning, or also about the chatbot design. So let's start something about what is a chatbot design, and let's try to see if it can answer something around it. Okay. So okay, so since we gave it a keyword which is chatbot design, it picked that keyword and it tries to answer that chatbot design is the process that defines an interaction between the user and chatbot. The chatbot designer will define the chatbot personality, the questions that will be asked to the users, and overall interactions, right? It can be viewed as a subset of conversational data. Okay. So yeah, so this is like in keyword, and based on the keyword, it has picked up well, and it is able to respond, right? So something like who was, I would say, Alan Turing. So Alan Turing was the fellow who basically uh, initiated the bot. So in 1950, Alan Turing's famous article, Computer Machine Intelligence, was published. It was the now called the criteria of intelligence, right? But if I start asking something, so what is the date today? Okay, so in that case, obviously, it will not be able to give me an answer because that has not been trained in this, right? So it's more of an, I would say, the definitive bot, but it is not as, it cannot search from anywhere, right? Because right now we have trained it on a data set which is static. Now let's see if we can connect it with multiple APIs, and it can basically Google search and find it out. Then basically it becomes a more intelligent bot, right? But most of the bots that we have right now, it's more of within that repository that we have trained, right? And that's how it basically works, right? So in this context, what we have is basically like how do you basically put a bot into picture? Okay, so few key things that we use. One is basically we use these kind of libraries like NLTK or Spacey, right? So which are basically the natural language processing libraries. This is important for processing your data into the language which the machine understands. And second, what we do is like we use all the analytic steps, like pre-processing steps like tokenization, lemmatization, right? And then what we do is like for generating responses, we use a specific module of NLTK, which is the SPAG first, and compromising of the TF-IDF approach and cosine similarity, right? What TF-IDF and cosine similarity does, guys? TF-IDF basically ranks the words with a certain score based on how important that word is. And cosine similarity basically tries to check the similarity between what the user is asking and what words matches in the database with the user responses, right? So that's what cosine similarity works with. And finally, using these two, we generate and score. And based on that, it basically generates the responses. If the responses are good, if the question that the user is asking is exactly same with what the database has, we see that it was able to give certain good responses. But something like which is completely out, which the data is not trained on, it will not be able to, right? So that's basically how and bot works, right? Obviously, we can make it more and more complex and make it more and more, connected with APIs and external cloud layers, right? But yeah, so I think that would be the next step from here. That's how we can basically use data engineering and more of, I would say, data pipelines to make it more responsive or more intelligent. Okay, but the idea for today was to not bombard you with too many, I would say, very advanced layers, but make you guys aware of what conversational AI is, what it does, what is the role of chatbots, how it works, okay, and also to show you how to basically work with a chatbot from Python's perspective. So I guess we are at time, and now I will, open the forum again for questions. And let me know, guys, how do you feel? How did you like? Did you guys, had a good understanding of what we discussed? And if you have any questions. Programming languages we use extensively AI applications of Ajit. Definitely Python is the one, is a key, along with Spark. So these are the two, I would say, programming languages which we use for building conversational AI applications. Any thoughts, any questions? I hope you guys were able to, follow, understand, get some takeaways from whatever we discussed.
Hello, sir.
Yeah.
So where we get the Jupyter notebook? You have.
I will share this with the team, and you can basically right, play with it, make it more, maybe train it on other data, and see how it works. So I will share.
Okay.
Yeah,
I have to contact with the team, or they will.
yeah.
Okay.
You will be shared. I guess you will be shared.
Okay.
No.
Thank you, sir.
Cool. What else?
One more question, sir.
Sure. Go ahead, Devesh.
Can you suggest me some projects for the Python?
So in Python, I think RB does offer a lot of projects in itself. So you can definitely connect with Sonia, Sonali, the team to have certain projects. In addition, if you want to do some open source ones, there are a lot of projects in Kaggle. So you can basically pick definitely not the Titanic case studies, but ones which are I would say more oriented with certain use case, right? So you'll get a lot of them in Kaggle or in GitHub, and you can pick them. And if you want some live case studies, you can definitely connect with Sonia and team, Sonali and team to basically have some case studies in that reference.
Okay, sir. So any case study uploaded on the YouTube channel?
I would say Sonia and Sonali would be the best person to answer that.
Okay.
So they have the repositories, so you can definitely connect with them.
Okay. Sure, sir.
Yep.
Thank you, sir.
Thanks.
Sir, this is Ajay. I have one question.
Hey Ajay, yep, tell me.
See, if we would like to go for the data science, okay. So since so there are many segment in data science like NLP, deep learning, computer vision.
Yes. Yep.
So which one is good for from the career point of view or from the job perspectives? Which one should we try for the specialization?
So I will say obviously it's not possible for us to learn everything, right, in equal focus. Okay. So if you want to start, if you have, so it depends upon you what kind of profile that you have, and what are your career aspirations, what is your industry background, right? And I
For
would
a
always
person,
say start
for
with
a
some.
technical person who is working as a MIS data reporting, dashboard visualization kind of thing.
Okay, so definitely you can pick the visualization aspect first, like on Tableau or Power BI, and then you can basically move on to the programming languages like Python to add the data science skills, right? So that's, I think, the way I will suggest you to pick up, rather than directly going into something which is very, very specialized and very, very niche, and you might not be able to give full justice to it.
Okay.
Yeah.
Hello,
So
sir. Hello,
I
sir.
think Sonia and Sonali can give you a very, very good idea about how you should
Sure.
approach.
Hi everyone. I hope you like this session. So today, like students who have attended the three days boot camp or 2 days boot camp, we have some offers on data science or the data analytics, and interested student can fill the form. The form has been shared in the chat box, so you can fill the form, and our team will be contacting you about your doubts in data science, data analytics, which course best suits you, and how you can move further. So, and we are also offering some discounts on that.
Okay.
Okay, ma'am.
Thank you, Sonali, for that key information for all the participants. I think that would be helpful. So I think, guys, for any I would say, career related doubts, I think they are the ones who will help you best, because Sonali and Sonia have worked with so many of us to help them transition to a career in data science. So feel free to reach out to them. And yeah, I am also there, and feel free to reach out to me. I'll definitely share my email ID with all of you guys, so that if you want to drop me email and ask something, so feel free to do that. Okay, but I would say first point of contact should be them, and they will be able to answer all your queries. Okay, so I hope you guys enjoyed the session. You will be getting the PDF and the notebooks, the Python notebooks. Okay, and I think you also, if you have attended all the three sessions, you might also get some certificates. So look forward to that. Okay, and do let me know. Do come back if you wanna how you have any questions. Feel free to reach out to me or to Sonia about anything which you want to discuss in detail.
Sure.
Sure.
We have filled the form.
Okay. Great. So thank you all. I think lovely to have you. Thank you for sparing that time in this Friday evening. And I hope you guys again you enjoyed, you learned, and you never know, we will meet again. Okay.
Okay. Thank
All
you,
the
sir.
best, guys. Thank you all. Cheers. Bye.
Thank you, sir. Thank you.
Thank you.